Hello, everyone. Welcome to our first session. Over the past 3 or so months, we've been having CTFs that have covered different areas in cybersecurity. So starting this week and going on into August, we'll be holding walkthroughs with the creators. So this is a chance to get an idea of how the challenges could be solved and also some perspective on other techniques that could have been used. Even if you already solved it, you can also learn a few things about the solutions. We grouped them into categories, starting with Linux, then we had networking, and then these were followed with other areas. So we'll follow the same format. The first area we'll tackle is Linux. That's the very first one we started with. Then we'll have subsequent sessions every Wednesday unless otherwise stated. Uh, for this week, we'll start with our creators of the Linux CTF. I'll introduce them, then we'll go through a walkthrough of the challenges. Each creator will go through the challenges that they created. So I think I can start with Hilary. Hilary, can go ahead and introduce yourself.
Oh, hi, I'm audible.
Yes, you are.
Oh, yeah, I'm Hilary Soita. I'm an application security analyst, self-taught at that. So yeah, application security is my specialist. I'm a specialist with application security, but I also do mobile and currently learning networking as well. So worked previously at Cellulant, and right now here I am.
All
Yeah,
right.
so
Thank you, Hilary. Next, we'll go to Emmanuel. Well, I think
Hi,
we can start with Numi. Let's start with Peter.
Okay. Hi guys. So my name is Peter Numi. I'm more of a tinkerer. I love tinkering around with things. Specialty, network security, vulnerability assessment, and red teaming, plus also low-level stuff like reverse engineering and the rest. Also, yeah. As I said, fun fact, I'm not a football fan, but I love rugby. Yeah.
Thank you, Peter. Next, we'll go to Emmanuel.
hi guys. Oh, I'm Emmanuel Okumo. I'm an infrastructure analyst. I specialize in network security, and currently, yeah, I'm learning more about network security research.
All right, thank you, Emmanuel. Then I'll finally introduce myself. So I am CK. I lead the mentorship program at ICRAL, and I've been involved in a few areas over the last few years. So I can't really say there is one specific area that I have focused on. I've tried a few areas here and there, and I'll be leading the walkthrough sessions from now on until the end. So I think we can immediately get into the walkthroughs so that we don't spend too much time and exceed our planned time duration. Hopefully this takes about an hour or less. So first we'll start with Hilary, and the challenge he will be walking you through is the challenge he created. So let me share the screen that shows the challenges. I know some people were able to participate in the CTFs. If you aren't able to, you can register at ciphercode.dev. So the first challenge we are going to cover is the yarn challenge. So from here on, we'll let Hilary take over. So Hilary.
Okay, so I hope everyone can see my screen.
Yes, we can.
Okay, so
go ahead.
This was probably the simplest challenge of them all. This was like the introduction for all the challenges that are to follow. So this is the yarn we have, ciphercode.dev. So we're presented with this image file, which is bin.jpeg. So guys were able to download this, which was hosted on the server. And I hope everything is okay. People can actually see me properly. Let me just zoom in. I think that's okay. So we had this bin.jpeg. So whenever we want to know the type of the file we are actually dealing with, we usually use the file command, and we have bin. So from this, you can actually see this is a TIFF image file. You can see a couple of sample data over there. And so the main goal of this was, I can categorize this as probably forensics because it involves some investigation stuff. So the first thing I did, or anyone was supposed to do, was look at the metadata. Since it's a CTF, we're going to assume some metadata was hidden inside here. So usually that's the format of the flags when you're doing a CTF and they're presented with an image file. So probably the simplest method is using EXIF tool, which is a tool for reading and writing metadata to different objects, be it text files, image files, and stuff like that. So we're going to do EXIF tool, and then we have our bin.jpeg. So we have a couple of different things. We can see the modification date, the name, directory it is, and stuff like that. So from here, we can actually see, so the XP title, from here to here, I just added some data, just not necessarily making any sense, but this was just test data to make sure everyone knows something was added, but from here you can't actually see anything. So if you only used this, you're only limited to what you can see right now, which is not part of the solution. And so digging in further, there's a command called strings, which actually usually outputs readable text or characters that are usually embedded in a file. This might be maybe a PDF file, actually a text file, image file. So using this, we can be able to extract any any strings, not metadata, any strings that are readable on this file that we have. So we can see have a couple of them. But to be specific for the challenge, we had a format. We had a format the flag was supposed to follow. So if you have time on your hands, you can actually go read through everything. Clearly, you can see the flag is here. But if you wanted to save on time, since you already know the format, you can just grab this. So you can just do this and just grab and we had the format right here, the flag, I mean. Pretty simple. That didn't even take a couple of seconds. Yeah, so that was it for my challenge, which was very simple and very basic and completely introductory.
Right, thank you, Hilary. You'll notice that the theme was to start from beginner as we build up the skills. So the whole purpose was to progressively build up your skills in all areas of cybersecurity. So expect the challenges to be beginner to intermediate. Towards the end, we started having some more advanced stuff, but still within solvability of anyone. So next we'll go to Emmanuel. Emmanuel created 2 challenges. One was called commitments and one was called time travel. So Emmanuel. While we wait for Emmanuel, I think we can be moving on to Peter. So Peter, are you ready?
Yes, I'm ready.
So let's start with Peter.
Okay, so I will start with the easy one, which was history. So I created three challenges. So let me share my screen. Can people see my screen?
Yes, you can.
Okay, so I created 3 challenges. So we'll start with history. Okay. I hope the text is clear. So for history, the main you were provided a zip file, which was lincoln.zip. And
hello, Numi.
Yes.
Could you zoom into the screen a bit?
Is that better?
It is.
That's better.
Yeah, it is.
Yeah, that is better.
Okay. So the main challenge, you were provided with a lincoln.zip. So when you unzip it, you'll find a folder known as Lincoln. So when we enter the folder, basically your main goal was to find the flag that is within here, somewhere here in the lincoln.zip. But when you look at this structure and you've been using Linux, you'll basically notice that this is more of like a whole folder from an Ubuntu desktop, right? So the idea was to show people the importance of history, which is a file in Linux known as bash history, where when you're starting to look around things, I will start around from there, where I will basically try and see, okay, so I'm looking for a flag, and it has like a flag, like, so I'll just grab for the flag here and see the R tag is for recursive, and see what it will get me. So yep, and our results shows us that within the bash history, we have more of a flag. And the user was created a text file called flag.txt, and then moved the text to a script, and then gave it permission to executed the script, and then from there did a cut of whatever is the script to curl somewhere within a domain ix.io, and then from there also saved, ran the same command but saved the output to cache.url. So seems like our output will be somewhere here in cache.url. So when you go to .cache/url, no .url, sorry, URL, we'll see whatever he did, he saved the URL in a text file. So when we copy it, okay, sorry about that. So when we copy it, let me open a new window. When we copy it and you paste it here, I hope you're seeing my window. Yeah, you will see AspireCTF. Then that's mostly the challenge. The challenge was more of showing you what's the importance of history. It shows, it keeps a history of things that you have run in your operating system, and commands and everything. So when you learned, like, that's the most important thing we were more teaching people about. So that was for the first challenge. For the second one, now.
Hello, before you go,
yes,
I have a question.
Yeah, ask.
Since I'm okay, like, let me say I'm like new to this.
Yeah.
We've used the previous person used grep function.
Yeah.
We've also used grep. So what does grep mean?
Oh, so grep. What does grep do? So grep is more of a utility for searching for things. Like, given an example, let me. So it's more of a utility. When you do grep -h, that search for patterns. Or let's go to the man page. It has a man page. So let's say you have a file, a whole file with a lot of data, right? Or a whole directory with a lot of data, and you want to look for a specific text or for a specific word in that directory or text. So basically, you will use grep to grep for to search or to get whatever is in that directory to in those files. So you're looking for a certain matching pattern of word or string in either directory or a file. But basically, it checks in a file. So if it's in a directory, it will go inside the directories and then checks inside the files inside the directory. So have you understood?
Yeah. So from there, what's the difference between grep, locate, and find?
Grep, locate, and find. Okay, so grep will get strings like a pattern. Let's say, example, when I was saying grep flag and then dot bash rc. Wait, it's bash history. No, sorry, bash history. So you see what grep will. Oh, sorry, I'm grabbing the file. Sorry about that. Let me go here. Flag. So you see, grep basically gets, you see, it's looking for the pattern flag within the file bash history. Okay, that's what grep does. With locate, it's more finding something. When you go to read the man page, now it will more it won't look for the strings or the pattern, but it looks for like files. Sorry, my man page. It will look for okay, locate. Okay, hey, I don't have locate. Okay, let me see. Locate dot curl. Yeah. Okay, I don't have locate. But locate and grep, they kind of work the same. No, locate and find, they kind of work the same way. Oh. Let me just install locate just a minute. So when you read the locate manual, so locate basically list files in, like, you see now with grep it looks for a pattern within the string. Now with locate it looks for a pattern of whatever you're looking for now for the files within directories and everything. So for example, like right now, maybe we were told to look for a file in somewhere here that was called .url. So you maybe say locate .url, and then here, wait, locate. Let me see URL. Gosh, let me try something first. Oh. So let me see, just a second. Okay, so let's say locate .url. That's what we're looking for. It's not here, but in .cache. Let's .cache. Oh, I don't know why locate is not working on my end. But locate basically looks for a file. Yeah, it looks for a file. It works like find. Let me jump into find, because basically locate and find works the same way. So I was saying before, we were looking for our file .url, because that we noticed that when we did a grep, I'm showing an example with this, whatever we're doing with the CTF challenge. We're looking for grep. We found that our output was being saved in .cache.url. So if you want to find the .cache.url, let's say we're told to find a file stored in Lincoln called .url, and you don't know the path, you will basically say with find, you basically say find, and then the directory path, which is this. This means the current directory path, and then the name of what we are looking for, which is more of URL, but it will have to have a dot, so that because our file starts with a dot. Yeah, and then from there we say the type, which means with find you can get both directories and files. So if it's a directory, you will have said type D, but now because it's a file we're looking for, the type will be F. And when you do that, you see we're finding our file which is stored in cache.url. So with locate, it basically nearly works the same way, if I'm not wrong. Have you understood?
Yes.
Yeah.
Thanks for clarification.
Yeah, you're welcome. So for the second challenge, it was, let me go back. So for the second challenge, it was more, it's called Matroska. So for this challenge, it was more geared to getting to understand different file types. You see, like the way we, like example here, the files when in Linux, the way it shows a blue color on the name of the file, it means it's a directory, okay, and which you can confirm with the -L. So this shows these files, it shows that it's a directory. This shows it's a file, but doesn't give you what type of file. So we need to understand these types of file types. So the command, before we get into the solving the solution, the challenge, the command to get to know what type of file you're dealing with, it's called file. It's called file. So when you do man file, man is the man page. So when you do man file, you'll see the file command basically determines the file type. So basically the challenge was to get to know and play around with different types of file types, okay? So right now, when you download the challenge, you are provided it will provide you the file.zip.
Hello, Peter.
So when you
Just a correction.
yeah.
The man is not the man page, it's the manual page.
Yeah, manual. Yeah, manual page. Sorry about that. Yeah, I shortened it. It's a manual page. Okay, thank you for that. So when you do file, so let's say, give an example like file itself, file.zip wasn't .zip. It would have been file and then no file.zip, file.zip, file. So when you do like that, you wouldn't know, is it a text file? Is it a, like the difference between file, let's say we do flag.txt to flag, you wouldn't know the difference between these two, okay? But if you do file flag, you will see this is an ASCII, this is a text file, and you do file, you will see this is a zip archive data. So you are provided with a file that never had an extension. So the first thing you will have done is more of unzip it. So and let's create our directory to place all the files there. Solution, and then we move. We copy whatever is in file to solution, because we know it's a zip. We solution slash file to zip, then cd solution. Okay, so here's our file. So the first thing you will have done is move, unzip it, and when you unzip it, it will give you a file .tar.gz. So next will be unzipping the file .tar.
Numi,
Yeah.
could you increase your font size?
I increase the font size again.
Yep. Again. Okay.
Yeah.
Yep.
Okay. Okay. So you will get a file 0.tar.gzip, which is more of a tar file with an extension of zipped gzip file. When you do file 003, you will see it's a gzip compressed data file. Data mov tar but gzipped. Okay, so next you'll be to unzip it, which will be tar x minus x zf, and then file 03, which will give you file 02. Okay, now you see when you keep on unzipping, you wouldn't see the file type. So next thing you'll run is the command file 02, and tell you it's a bzip2. This is more a file compressed. So that's the challenge, basically trying to make you understand the different types of extractions, and it's really good to understand them and to know how to unzip them. So after that, we'll be more unzipping it. Also, do note that if you don't understand how to unzip it, Google is your best friend. Always remember that. Wait, give me a second.
Nomi, as you're taking a break, we have a question, or
Yes,
rather a
ask.
request from YouTube.
Yeah.
Is it possible for you to increase the font size on your terminal, please?
Again, okay, let me switch.
Anasema ati haoni.
Okay, wacha ni switch basi. Dakika moja tu ni switch.
All right, thank you.
You're welcome.
For anyone with questions, please type them in the chat so that it's easier to follow up on and to ensure that we don't miss anything.
Is this better?
Yes, that's much better.
This is much better.
Yeah.
Okay, then. So as we were saying, now we are back at the bzip2 compressed data. So as I was saying, you don't need to understand, you don't need to cram or mostly cram or have how to unzip these things from your head. You can Google always, but it's usually good to understand that bzip is is more of a type of compression. So next will be unzipping it, which you'll have to install the bzip2 if you don't have it. And then -d means decompress, and then our file, which is file 02. Yep. So it gave us a file of file 02.out. Why it gave us that? It's because we changed the file name, so it will just give a new name, which is .out. So next will be more of file 02. Getting to know the file type, which is more of another type of compression, XZ compression. So this time we'll have to give it the extension .xz, because most times when you uncompress this without the extension, it wouldn't work. Let me just show you an example, which will be more of xz extract. Wait. Extract file 02.
I think Numi was cut off at some point. So while we wait, I think I can be continuing with where he left off. So let me also share my screen. I hope that's okay. So we were in the Matroska folder, and what Peter was doing is showing you how to understand what the file types were and extracting them along the way. So I'll go through the first few extractions he did. Hopefully he will be able to join before we are done. So first thing is we had a file called file.zip. And it's a zip file. So he already unzipped this file. Then I think he had also already gone and extracted this file too. Then after that, I think he also went beyond this. So let's go to the next part. We discovered it was a bzip file. So he used the bzip utility to extract that file too. So now we had this file, which he also analyzed, and we realized it was an XZ compressed data. So what he was trying to say is Sometimes you have to rename the file, because if you try to decompress it without renaming the file, some tools like the XZ tool isn't able to decompress it because it doesn't know what its name is. So most of the times you'll have to rename the file. The tool you use on the command line of Linux is usually the move tool. So it's literally moving the file from moving the file to another location with a new name. So that means the original one is deleted and you have a new file with a new name. So if we rename this to .xz, then we should be able to now uncompress it. And we should have a new file here. I think Numi should be back by now. I think this is where he left off. So if Numi, you are able to share your screen, you can continue from here.
Okay, I'm sorry about that. I'm sorry about that. So let me share my screen. Oh, kindly enable me to share the screen. Okay. Yeah. Okay, so yeah, we were here now. Let me increase my terminal and then I zoom in a bit. Is that better?
Yes.
So he explained more of the whatever I was trying to explain. You have to move the file 02.exe and then to remove, to decompress, move, let me do it. Okay, so next we have our file 2. So when we check the type of file, which is MOV compressed, another gzip compressed, which now shows you it was flag.txt.z. Okay, so decompressing this will be mainly, let me see, yep. I'm using the uncompress. So knowing that, it was this, we'll have to rename it back to this. He explained. So we'll have to rename this .2 to file 02 dot .z. And then from there we uncompress file. And then from there we have our file 02. When we do file 02, compressed data bits. Right. Okay. Let me try and save. Nope. Okay, so it's when you do a file again, sorry about that, I'm a bit confused. It's compressed still, but now this time with data 16 bits, which is a different type of, let me show you from the Google. This is more, yep. Yep, so when you uncompress this, it becomes a 16 more data bits, which you'll have to still but we have to get our file. I don't know why it's, Has the file changed?
Numi?
Yes. Has the file changed?
I think in the previous step, you renamed it to .z instead of .gz.
Yeah, but yeah, it was supposed to rename to .z. The 16
Go back.
bits. Let me see.
The previous compression, the renaming.
Yeah.
So the file 0.z should have been .gz instead
.gz.
of .z.
Oh, instead of .z, and then .z. Oh. Okay, so we'll have to. Let me see.
Since I'm already at that point, I
Yeah,
think I can actually
continue.
pick up from there.
Yeah.
Let me see where we are. So we had already uncompressed the file up to this point. I know some people may be wondering what these tools are. So these tools are decompression tools. They compress and decompress files. So there are various file formats that are used in compression. We usually have the zip files that most people are familiar with. We have the .tar files that are also very common in Linux. We have the .xz. So there are a lot of file types that you can use to compress Linux files. So you really don't have to cram these tools. Once you identify a file type, just Google what file type that is. So like in our case, when we identified that it was XZ compressed data, just Googling this will what type of file it is and the tool you need to decompress it. In our case, it was the XZ. So at this point, if we go to file 02, we are told it's a gzip compressed data from here. So if you go Google what a gzip compressed file is, it will tell you. Then, first of all, we will rename it to have that extension. Then we will use the gzip tool to decompress the file. And now we'll have our new file, file 02 again. And now it will tell us it's compressed data 16 bits. So from here on, once we get compressed file data, what we need to do is, again, I hope I got this right. So what you do is go Google what this type of file is. Compressed data 16 bytes. If you Google what this file is, you'll be told that it's of the file format .z. Now this is where you now remade it to the file 02.z. And after that, then you will be able to uncompress it. Then at that point, you will have, again, a new file 02. And in our case now, it's text. It's a text file, and in this case, we can just view what the text file has, which should give you the flag at the end. So this whole challenge was about identifying file types and learning about the different compression tools. So as you can see, we've used a lot of them. We've used the uncompress command. We've used the gzip command. We've used the xz command all the way until we found the final file which had our flag. So from here, I think we'll go back to Numi for the escape challenge.
Okay, thank you for that. Now the last challenge, before I share my screen.
Numi, there's a request on the chat. Huh? Mr. K is K3V, or is it a miss? Sorry. So they say they're not from a computing background, and they're requesting that you be a bit more, explain these terms, explain some of these things.
Oh, okay.
Yeah, thank you.
Okay, so
hello, Shay. I think as we've explained, most of these commands aren't static. So there are different commands that do different things. So the thing is, once you identify something, let's say the complexity, all you need to do is go and Google what this type of data is, then it will give you what tool to use. The major thing is to learn what to do next. Then at each point, once you identify what type of file is, then you will have, because like in this case of the file 02, it was a gzip compressed data. So just Google this, and Googling how do you uncompress this type of file will tell you need gzip, and it will give you the command. So basically, don't get hung up on the exact command that was used, but be to learn the process.
Thank you, CK. I hope that's clear now.
Okay, so next is the escape challenge. Let me share my screen. Can everyone see my screen? Is the text visible properly? Sorry.
Seems good, Numi.
It's good.
Yeah.
Okay. So for this challenge, I think I will do it from the other end. Let me do it from the other end, and then I will explain the dynamics of it instead of starting from here, because it will be, I think, a little bit more technical. So safe code dev. Let me just enter into the challenge and get the SSH. Escape room. Okay. So for this challenge, you are provided with a IP here, such an IP, and then you are told to use the credentials escape. Okay, so username is escape. So SSH is a command line utility to log in into servers using the SSH protocol. So that's how you log in. SSH, the username, and then the IP of the host. So once you do that, it will give you, enter the password, escape. And once you enter escape, it tells you AspireCTF. And then once you press or you go more, it terminates you and tells you the flag, I am somewhere around, find me. So basically, sometimes you'll find yourself, the main challenge of this code was to try and escape whatever is happening right now. So there are different ways of doing this. One of them will be when you play around with the SSH commands, will be maybe running a command, and you do ls, and it will run, ask you for the password, and then bring you it runs the command and shows you the flag.txt and look.txt, and maybe you can say, okay, so I've seen the flag.txt there, so you can do flag.txt, and then you get the flag. That's how to run a command directly using the SSH protocol. Like, that's an easier way of doing that. Okay, that's an easier way of escaping it. But the main challenge of how we wanted you to escape this, it's more of you play around with whatever. So whatever is popping you out right now, you'll try to understand. Okay, it's giving me the more like, it's more in an editor mode. So what if what happens is you will research more of how to escape from the more of the view thing. Like, how will I escape to this? So you will be required, sorry, I'll have to now, you'll be required to reduce your screen size. Okay, and then, sorry about that, right? And then you SSH into it. I hope you're seeing. And then you enter the password, and then it will be more of, now this time round, oh wait, why is it not working? Okay, yeah, you'll press V, and then once you press V, it will enter you into more of the editor now, once it's like that. So with that, now you're more in the Vim mode. So with that, you can spawn a terminal. So Vim is editor. It's a command line editor, but now with this, now you can get to play around with it. Like, where are we? Oh, what's happening? Okay, let me just. Oh, okay. So with this, you can run commands and you can say flag. Sorry. Let me just show you how it works, and then from there I explain. Okay, what's happening? Command. Wow. I'm having my terminal, but I can't see whatever I'm looking at. Oh. Oh. Okay, let me try something else. Yeah, you can open the file. Sorry about that. So what I basically did is more of open the file in an editor, because I knew the file is there through previously trying to ls and everything. So there are different ways of escaping this. I would recommend you to look at what is it called? This challenge. There's a challenge. I learned this from a different challenge while I was doing over the wire. Let me just show you. Let me change my screen where I can share it. I will recommend for people who are starting out, you can try and do these challenges. That challenge was more of the last one, the level 3 to level 34. It will teach you the basic skills of more of the essentials to have ideas while playing around with commands and everything. So you have to learn about a man command to see the manual of a command and to understand the command better and everything. So there are different ways of solving this. I hope I've explained properly, though I would suggest, I gave the first easier way. For the second one, I would suggest you to check out this last challenge, level 3 to that. No, sorry, level 29. Somewhere here, yeah, here, how to solve this, but you'll have to start from level 0 till there so that you can get to solve it. It's usually interesting. Okay, I think that's it for the last challenge. Any questions? Oh, shit. Any questions? Oh, Kev asked, how did I open the file? So for the file, let me explain it here. Let me share. Ooh. So how I opened the file is I used, so let me exit the challenge. So the challenge basically utilizes Vim VI itself. So I escaped through the more and entered I pressed V when you reduce the screen. Let me repeat it again. When you reduce the screen and you try to SSH, it will give what basically happens is SSH now. Wow. Oh, sorry. Let me remove this. When you reduce the screen here and SSH through it, when you reduce the screen, that's it. Now what happens is because we're running the more commands, the server allows you to try and play around, like, because the terminal and the text is small, it allows you to escape. The more has a bug whereby once you press V, it allows you to enter into an editor mode so that you can able to read the file in an easier way. And the default editor it will use is Vim or VI, whereby VI is more of, so once I pressed V, just a small V, it's VI. So once I'm here inside, I am able, with VI, you're able to run commands and everything. Like an example now, I'm able to, like, let's say a list files. Sorry, I'm able to list files that are here. You see, that's a command I've done. The exclamation mark and then ls, you're able to list files, but you're also able to open another file within here once you know the path, because we know the path. We know there's a file known as flag.txt. So we can say flag.txt, which opens a file. You can also escape Vim and enter to a terminal. You can also do that from here and have the whole terminal where you can just say term, which is more of terminal. From here, and it will give you, but now this time it keeps on giving you terminal and the Aspire, because that's the main challenge of the code, like try to read without escaping. So that's why it was giving us an issue, but that you can also do that. That's can be an extra challenge to try and research about, but you can also do that. But yeah, so that's how I've opened the file to Kev, Kev, have I answered your question? Yes.
All right, thank you, Numi.
Okay.
I think we can now go back to Emmanuel. I hope Emmanuel is now able to share his screen for the two challenges he created.
Yes, let me share my screen. Can you see my screen?
Yes, I can increase the font a bit.
Okay. Is that better?
Yeah, that's okay.
Okay. I'll be taking you through the commitments and time travel challenges. So when you download the commitments zip file from the challenge site, you will find a folder that has several files and other folders. So when we run ls, you can see the folder Fluent UI, the license, and a README file. So when we run ls, list everything, we can see we have a .git folder, meaning this is a project folder being tracked using Git. Git is a version control system that is usually used by developers. So we start by running Git, Git branch. Okay, Git branch. To know how many branches are in our Git folder, you can see we have the master and the dev, which most probably means developer. Git usually has a subcommand called log, which can be used to see everything that was done during that session. So when we run git log, we can see we have several commits, to the master. When we scroll down, we can see we have other commits plus another commit to the dev. When we scroll through the commit messages, you can see basically Git usually follows the format, the commit plus the hash, who the author was, the date of the commit, plus the message. When we scroll through these commit messages, we can see our flag is part of the commit message. Here, Aspire juicy info. Yeah, that string is our flag. So we can exit our Git log. Another way to solve this challenge is by running git short log, which is another subcommand. It gives us our commit messages in a cleaner format where we can see our git message, git commit message, and we have our flag here. Any questions concerning this challenge? Okay, if there is none, I'll proceed to time travel. Okay, so time travel is also another Git folder. If we ls and list everything, we can see the .git folder. We can run the previous command to see how many branches we have. We can see we only have one branch, which is the master. To see all the commit messages that were done previously, we can run git log again. For this project, we can see we have several commits. Okay, apparently it's a Django project. And part of the message you can read here, there was an initial commit, which is the very, very first commit. Then the second commit, the developer might have realized maybe they had committed something that was sensitive. So part of that commit is the message is redacted sensitive information. And the developer continued committing other changes to the project. So we can use another subcommand for Git called git diff. which is used to show the difference between the various commits. So we can copy the old hash, this one here, and a newer hash to see the difference between the commit messages. So when we run git diff, the old hash plus the new hash, we can see some of the diff in the project files include the flag which we're looking for, which is aspire this. Another way we can go about this, we can use the git log command and pass the option P, which stands for patches. Patches is it shows the different changes that were done in the source tree we are trying to look at. So when you run git log P, it will show us the differences. So like for this commit message, you can see the difference is the developer deleted whatever this was. Anything in red is whatever was deleted in the previous commit. As you can see, we have a lot of commits, which makes it hard to see through our information. So we can pipe this through grep and pass the option O and E. O will only search for the string we want to look for, and E uses an extended regular expression format. So we can pass our flag string aspire, the curly braces, and this is a regular expression to search through our log messages and to find anything that matches this format. So when we run that, we can see our flag appeared somewhere in the Git logs. And that is all. The main purpose of these challenges was to start off the whoever wanted to do the challenges with simple Git commands to familiarize yourself with Git. Okay. Does anyone have a question?
All right, thank you, Emmanuel. Think we'll move on to the other challenges. If you still have any questions, please type them in the chat, then we'll come back to them. So the next challenge we'll go to was called Needle in a Haystack. You are given a zip file and you are expected to find the flag. So let me share my terminal. So first of all, there is the file you are given. It's called haystack.zip. So let me first remove the directory I had extracted. So once you have a file, the first thing you do is extract it. So unzip is the terminal command to extract files. Most of you probably are used to the graphical interface, so you can still extract it the normal way you extract zip files, but for now we'll use the terminal. So once you extract the file, you'll have a folder called Haystack. So we can move into that folder by changing directories to that folder. And if you view the contents of the folder, we'll have files there. So different files, some have text, some are images, some are PDFs. So you can view a few of the files, let's say. So as you can see, it's a lot of text. So finding for the flag manually is going to be hard. So let's try view a different file. Say there's another text file called Phineas. So again, finding the flag is going to be pretty hard. So I think Peter had already talked about how you can use the grep utility to search for patterns in files. So again, we are going to use the grep utility. We are probably going to use a few other switches that you can apply to the grep command to help you narrow down your search. So the first thing would probably to search for the word Aspire, because as per the challenges, the flag format was to be in the format of Aspire. Then the flag was supposed to be in between some curly braces. So the first thing you can do is probably just search for the word Aspire using the grep tool. So a good thing with grep is it allows you to recursively search for all the files, for a string in all the files in a path or in a folder. So in this case, we'll search for all the files in this folder and we'll search for the string Aspire. And we see we have one result. The result is in the rlf.txt file, and the string was part of this sentence. So from this, it actually tells that we probably need to look elsewhere. So before we even proceed, let me show you one other switch we can use. A switch is just a way to modify the command. So you can use switches to manipulate what the command does. So another switch you can use is the O. When we use O, it will only output the string. In this section here, it gave us the full line where the string was found. If you only wanted to see the word Aspire, you can use the -O parameter or switch. So in this case, you see it only gave us the Aspire output, but we still aren't able to view our flag. The flag was the princess. The princess is in another castle. So another thing we know is that the flag has the curly braces. So the flag should be of this format. So the purpose of this exercise was to teach you how to use regex patterns. A regex pattern is a way to specify the type of pattern you want to look for. So let's say I want to look for all the strings that start with A, all the lines that start with A. I could use a wildcard character. So the wildcard will say, search for all files that start with the wildcard, and then followed by search for all files that have the word Aspire at the end. So if we did this, there aren't any, but let's say we search for one that has this. Let's see. My wildcard seem to be misbehaving. Let's see. So let's start with just the wildcard. So the wildcard will search for everything that can be viewed from all the files. So there are various regex patterns you can use. The best way to do this is just go to the help of whatever command you want to use, and you can see the wildcard that you can use. So like for grep, if you go to grep help, There are some parameters you can use. Let me show you, like the -w will tell you to match only whole words. The -x will match only whole lines. So you can apply different patterns. Also, there are a lot of materials on Google that can help you modify your patterns so that you can be able to search for specific strings in a file. In our case, what we want to search for is our flag, which we know will be inside the curly brackets like this. So I'm going to show you some switches you can use. So we are going to start with grep. Then we'll use O. I already talked what -O means, but you can also see it from the help menu. The -O should tell it to show you only the matching strings. So it won't show you the full line, just the matching string. The R, as we talked about, was recursive. That means it searches for all the files in that directory. Then we can now start searching for the string we want to search for. So we want to search for something that has the curly braces. Then there's a regex called that uses the /w. The /w means a character within a word. So we should have a character within that word. That means that the curly brackets shouldn't be empty. So that's basically what we are saying there. So it should be curly brackets and it shouldn't be empty. Then we want there to be more than one character. So if you want to tell it to have more than one character, the switch we use is /+. So this will tell it to search for any string that has these curly braces. It isn't empty, so there's at least a character and more than one character. So to learn about these regex patterns, a lot of it takes exercise, then a lot of it takes Googling and seeing what other regex patterns people have used. Then pretty soon you get used to them. Then if we do that, we'll finally see that we are able to see our flag here. So that was the Haystack challenge. If you have any questions, still ask them in the chat. As I said, any of the terms I mentioned, please go ahead and search for them, Google them, regex patterns. If you don't know what a regex pattern is, it's a pattern that you use some modifiers to match. So in our case, we used the /w as a modifier for the regex. /+ telling it to use more than one character. There are, I would say, hundreds of them. So don't really worry about cramming them. There are references for them and so on and so forth. So the next challenge after that we haven't covered yet was the Shapeshifter challenge. For the Shapeshifter challenge, what happened is you are given a PDF. The PDF was called Proceedings. So I'll try and open that PDF, then share it. Let me open it. So this was the PDF. I hope everyone can see it. So it was just a one-page PDF. So ideally, you are supposed to be able to try and figure out where the flag is from this PDF. So let's go back to the terminal. The very first thing you should do when you have a file is determine what type of file it is. In our case, we can go and check what type of file the proceedings.pdf is. You probably could guess it's a PDF from the extension, but be aware that the extension can be changed. So it's not always a reliable indicator of what type of file it is. So if we go check the file type, we do confirm it's a PDF document. Then I think Hilary also took you through the EXIF tool, which checks for the metadata in a file. Metadata is just information about something. So the metadata of a file would be details like when was the file created, who created it, what type of file it is. So again, we can also use that to see if we have any interesting metadata. So again, we have modification, creation, but no sign of the flag. I don't know whether people have interacted with the hex dump utility, but a file is made of bits and bytes, just like the knowledge people have been taught from either your school, if you haven't been taught about this, but the basic building blocks of a file are bits and bytes. So there are utilities that you can use to break down a file into those bits and bytes. So hex dump allows you to view the file in the hexadecimal format. Hexadecimal format means that every 8 bits are converted to a byte, and the bytes are now displayed to you, the bytes that make up that file. There's a hex dump tool in Linux that allows you to view files in those bytes. So the -c is another modifier that will allow us to have a proper formatting of our view. So let me view the file again. As you can see, the file is broken down into its hexadecimal bytes. And the other thing I wanted to show you is the start of a file. The start of a file in Linux usually determines what type of file it is. I would suggest you Google the term magic numbers. They determine what type of a file it is by how a file is constructed. So there are various types of magic numbers. Let me share a link that you can use. I'll share it on the chat, and also I'll open it in a browser so that you're able to see it. So first, let me share my browser. So everyone can see the file, I hope. So as explained from this page, magic numbers. Let me show you where they are. They usually indicate the file type. The magic number usually indicates the file type. So the magic number is most likely going to be the very first few bytes of a file. So in our case, these are the very first few bytes. If you view it in the ASCII format, you can see it actually says PDF. But going back to the PDF page, to the reference, you can see there are different signatures. So what you should do is you can come to your terminal, open the file. So let's go back to the terminal. So once you open the file in Xdump, check the magic numbers, whether they actually refer to a PDF. In our case, this is okay. But just to confirm, let's go and search for this magic numbers in our in the page I've shared. So if I search for that magic number, as you can see, it actually tells you it's a PDF. So in addition to magic numbers, the end of a file is, some files have the end of its file indicated by a trailer. So the trailers are also hexadecimal bytes that indicate the end of the file. They are usually called trailers. In our case, if we go back to our terminal, and scroll down the file, you will notice that there is an end of file marker at some point. And this end of file marker means that the PDF ended at this point. So in that case, that means there is some extra data that has been added to the file. So what is this extra data that has been added to this file? So one thing we can do is we can go check which file type starts with PK. So I'll copy this and I'll go back to my reference on the browser. If I search for that, in our case, it was PK. You'll see that PK is the zip format. So we know that after the PDF ended, there was some additional data that was added there, which was PK. So since we know how to extract files from a zip file, we could basically go and try and zip this file and see if we get any data. So let me see if that works. And as you can see, it says inflating, and there's a file that was created called versatile. So if you view what type of file it is, we see it's a text file. And so we can view the file using the cat command. And there we have our flag now. So as I had mentioned before, the extension of a file may not always be what you think it is. So the best way to confirm that is usually to check the file type using the file command, and then you can go deeper and check the actual magic numbers. And the magic numbers, as I have said, determine what type of file it is. That's how Windows or Linux knows what type of file it is. It reads the first few bytes of the file, then knows what type of file it is. So that was what was the name of that challenge? Let me confirm. That was the Shapeshifter challenge. So next we'll go to the challenge called Broken. Under the Broken challenge, you are given a file called broken.zip. So let's go to where I have saved that file. So you should have.
Sorry to interrupt you.
Okay.
There's a thing on your screen, and it's taking some part of the screen. Could you just remove that?
Okay, let me see. Is it okay?
Yeah.
Okay. So we have the broken.zip file that is part of the challenge. So this is the file that you are given as part of the challenge. So again, it's a zip file. So first thing we do is just check the file type just to be sure. Then it should tell us it's zip data. So we can safely go ahead and unzip it. Once we unzip it, we find that we have several files. So let's list them actually. So we have a lot of files, starting with broken AA all the way to broken AW. So this seems to be several parts of a file based on how they've been labeled and their naming scheme. So again, we check what file types they are. So I'll check the first, the second, and probably the last. So if we check the first one, we see it's JPEG image data. So let me check the second one. The second one just says it's data. So I'll check the last one, which should be this one here. And again, it's data. So let me try opening this file since it says it's a JPEG. So I'll go to the folder and try open it, then I'll share my screen. So when I try to open it, this is the message I get. Could not load image broken AA. So there was an error interpreting this. So again, from what we just covered in the previous challenge, we can first of all open it in Hexdump and see whether it's actually a JPEG file. And as I said, the best way to do this is to check the first few bytes, which are the magic number. So in our case, if we come and search for this, I'll go back to the site that I had opened. I'll share the link, so don't worry about it. So if I go and search for that, the first few bytes, yeah, I confirm that it's actually a JPEG image. But one thing you'll notice that the trailer is supposed to be FFD9. So if we go back to our terminal, let's confirm whether we have that as our trailer. Nope, we don't have that here as our trailer. So this means that our file is broken. So in that case, let's open the last file that we had, which was broken AW, and see what the end was. And we see that it actually has that trailer that we were looking for, the FFD9. So this can tell us that these are all parts of a file that have been broken. And from the name of the challenge, that should also have given you a clue. So the good thing is that they are progressively labeled AA, AB, AC, all the way to a W. One way you can join files is using the cat command. If you assign several files to the cat command, say, let's say I say broken AB, then output them to a certain file, let's say test. It will combine and merge the two files and save them to a new file called text. But in our case, we want to do it for all the broken files from broken AA all the way to broken AW. So one way we can do that is use a wildcard. A wildcard just means anything that matches that. So we know that all of them start with broken A, from A, B, C, D, all the way to W. So we can put a wildcard here, then it will merge all these files and save them to, we can call it flag.jpg or something. So once we do that, we should have a flag.jpg file. And then if we try opening this, we open the file, we should now have a file that properly opens without any errors. So we open this. So once you open that, you get your flag, which means if you submitted this, you would have gotten the correct response. So that was that challenge, just to teach you how to, again, analyze files, determine what type of files they are, and also how to merge them. So let's go on to the next challenge. Again, for any questions, still type them into the chat. Again, these videos will be available, so you can always reference them now and in future as you learn. So whatever you see being demonstrated, go practice, Google, learn, and eventually you'll become better at it. So the next challenge we haven't tackled is the backdoors challenge. So for the backdoors challenge, we had the challenge that asked people, let me share the actual challenges so that you see what they were asking for. Okay, so I hope everyone can see. These were the challenges. So I think the two remaining ones are the backdoors one and the backdoors hide and seek. So we'll start with the backdoors one, which said the host has a backdoor you can access. Use the backdoor to get the flag. No brute forcing or port scanning is necessary. Use the following credentials to access the server. So first thing we probably should do is log into the server using the SSH credentials provided. So that's what I'm going to do. So let me see. So I hope people have interacted with SSH. So SSH is a way to remote a server remotely. It gives you a terminal, a remote terminal. So once you log in to the server, you should have a terminal that has your username as talent, then the host name of the server. So we were told that there was a backdoor account on the server. So in most cases, a backdoor will mostly be a listening port or something that an attacker can connect to. The port then would be hosting an application or something that is accessible to the attacker. So the attacker would then be able to connect to it and then be able to access your server. Some of the ways you can identify if you have a backdoor would be to use tools like NetStart. NetStart shows you what ports are open. So if you use NetStart, then use a few switches. T means for TCP. L tells it to show you all the ports that are listening. Then N tells it to show you the numbers and the ports. So if we do this, we should have a list of all the ports that are listening on this server. And if there was a backdoor, ideally, we should be able to see a suspicious port. So if we do that, we see there is port 22, port 53, port 22, and port 53. These are the regular ports that we know of. 53 is usually used for DNS, so it's highly unlikely to be DNS to be the backdoor. Port 22 is usually the SSH port. That's what we've connected with. So it's unlikely to be the backdoor. So seems the backdoor must be hidden somehow. Next, we can search. NetStart used to be the common tool used to show open ports or closed ports or listening ports, but it's slowly been phased out. So if you've been using NetStart all along, you should start migrating to a tool called SS. It's what is eventually to fully replace NetStart. NetStart has still been around. It hasn't been deprecated currently, but at some point it will. So it's a good idea to start learning SS. The good thing with SS is that a lot of the usage of NetStart has been transferred to SS. There are some changes, but they're the same. So again, we can actually use the same switches we used when we were doing the NetStart one. And again, it shows us that we have port 53, which is usually the DNS port, and port 22, which is usually the SSH port. So again, these are unlikely to be the backdoors, which now again complicates the situation because it becomes a bit harder to track the backdoor. Some other tools you can use are tools like PS. PS lists the processes that are running. Then there's usually it's usually PS AUX that will detail you in a well-formatted manner all the processes that are running. So we do that. There's a list of all the processes. Again, very hard to identify the backdoor unless you actually know what the process name is and so on and so forth. So if the port is hidden, how would we be able to identify a hidden port? So one way would be to try to connect to every port on the server and see if any port responds. There are various ways you can do this. The common one that people know of is Nmap. Nmap is a scanner that will try to connect to every port and determine whether the port is open. So let's see if this server has Nmap. The which command checks for the availability of that command. If that command is not available, it will not respond with anything. So unfortunately, we don't have Nmap on this server. If you don't have a scanner like Nmap, in most cases, you should try to create a simple port scanner yourself or a simple scanner that you can use to scan for the open ports. People prefer Python. It's one of the beginner languages usually recommended for learning the skills you need to do basic scripting that is useful for Linux. So let's see if we have Python. Again, we don't have Python. So what if we tried to install any of this tool? So let's try install nmap. Let me copy the password. Again, we are told that this user is not in the sudoers file. The sudoers file is a file that determines the permissions of different users on the system and basically it determines what and who can do what on the system. It's a permissions file. So to install applications on Linux, you actually need to have certain rights, which, as we are told, Talent doesn't have. So we actually can't install these tools. So another tool that is useful for identifying open ports is net. On Linux, it's usually the nc command. It's a short form for netcat. Let's see if we have it. And luckily for us, we have netcat. So what we can do is we can see if we can use netcat to try and identify if there is any open port that we missed from our commands. I know during the solution, people used different techniques. People are able to use those techniques because there is one final security measure we didn't put. So people used grep and so on and so forth, which wasn't the intended challenge. It was supposed to be a bit harder. So I'll go into the intended solution. So netcat has a mode where instead of just connecting to an open port, it just reports to you what ports are open. So the command you usually use is nc for netcat. -v means verbose. Verbose means that it will display information of what is happening or any messages that it has. Then the Z is now that what tells it to only report the status of a port. So in our case, we are also going to just specify our localhost. 127.0.0.1 means our localhost, which is our IP of our server, the internal IP of our server. Then let's say what port do we know is open? Let's say port 22. We know port 22 is open. So if we do that, it will tell us it succeeded. Let's try a port we know isn't open. 23 isn't open. So if we try that, it will tell us that port 23 isn't open. So for specifying a range, we can just use a hyphen to specify the range. The total number of available ports on a Linux machine is usually 65,535. So if we did this, it would go through all of them and trying to see which port is open and which one isn't open and give us messages. If it's open, it would say succeeded. If it's not open, it would say connection refused. So if we do this, it will go through all of them until it gets to the end. It's pretty quick, so let it finish. As you can see, as it goes through this, it's pretty hard to identify what succeeded and what was refused because it's a lot of information that is being output onto the screen. So we need a way to filter out this excess data. So in Linux, there there is a stream or an output stream that is called standard error. So that stream is what outputs the error messages to our screen. If we wanted to redirect those error messages to a location other than our terminal, we could specify it using some additional parameters. So again, don't cram this, but what it tells us is to redirect the output away from our standard output to somewhere else. So if we do that, we are basically telling it to redirect our error messages and our standard output. Then, as we realized from our initial ones, we don't want to see the refused messages. We only want to see the success messages. So I can search for that string in our output, which should be succeeded. And then once we do this, we should only receive the ports that were open. So we have some open ports. So let's try to connect to them and see if one of them is our backdoor. So let's try this. Again, Netcat can allow you to connect to an open port. And these are the parameters you use. Again, verbose. Then the port is 3177. So we were told that it succeeded. So if we succeeded and connected to an actual backdoor, we should be able to run commands on the backdoor and interact with it. So a good way to identify is to identify a backdoor, or whether we are in a backdoor, is to determine if we are a user who has some permissions on it. So the best way to do that is usually to run the ID command. So it should tell us what user we are and what permissions we have. So once I run the ID command, it tells me that there's a user called backdoor. And this value here usually references a certain permission level. So the lower this number, the higher your permissions. So for the root user, this would be 0. But for normal users, it would be a much higher number. So it seems we've identified our backdoor. So another thing we can do is check what directory we are in. PWLD tells us what our directory is. We see we are still in the home talent directory. We can change directory to now the backdoor's home directory, which should be home backdoor. The home folder usually contains folders for the different users. So if we go to that directory and then confirm again that we are in that directory, we can confirm that we are now in the home backdoor directory. Let's see what files we have. And we have a flag.txt file there. So let's view the file. And there is our flag. So that was the intended solution. Luckily for some people, or unfortunately for others, we hadn't added some other measures to prevent them from being able to directory grep for the flag from the other user. So let's exit from this. So that was the solution. Then part 2 of the challenge was, again, if you have questions, ask them and I'll come back to them. So finally, the question was the backdoors hide and seek. So you solved it. That was the easy part, but how was the backdoor hidden? So I think the first thing is you would have to realize is why didn't NetStart and why didn't SS detect the backdoor? So let me switch back to a terminal. And what we will see is, let's go back again to NetStart and SS and try search for that backdoor. If we look for all listening ports again, we still can't see that port, but we know it's listening. If we do again with SS, so a normal administrator, system administrator would probably be running this command to see if there's some weird ports running and so on and so forth. So for this technique, it's actually some technique you'll actually see being used by malicious attackers to hide their backdoors. So how was this hidden? So a good thing would be, why isn't this SS command detecting this backdoor? So what is the SS command? The SS command is a file that basically has some instructions to do some things. So again, we can find out which command this is, and we see it's the user local bin SS command. There's another command called where. The where command is used to figure out where a certain file name is. So if we type where, not where is, it's actually where is. If we do that, it will tell us where that file is. So we can see there's a file called user bin ss. There's a file called user local bin ss. And this is for the manual pages. So why do we have two of these? So this should now start looking suspicious to you. And once we asked which SS, it said this one. Why didn't it say this one? The reason is Linux uses paths to identify what a command actually references. So when I type SS, what I'm telling it to do is actually run this full command. So how does it know this is what it's supposed to run? So when I typed SS, this is what I ran. So let's actually then run it with the same parameters. So this is what that SS did. So why did it choose to run this command instead of the other one that we saw there? Because we saw two of them, but not this. So how it determines which one to choose is there's usually a path environment variable. These are some, I would call them references that the terminal will use to check for what to do and what, in this case, what is the order of the paths to use. So when you do this, it will list all the paths that it will check for commands. So when I run the SS command, it will come to this folder here first, check whether there is an SS command. If there is no SS command there, it goes to this folder, checks whether there is an SS command. If there is no SS command, again goes to this folder, checks again and again. So again, now you can tell why this was the one it ran, because this path here, which is, where is that? User local bin. This one here, it should be this one here, comes before the user bin. So the user bin comes after it. So instead of using the SS command here, it used the SS command here. So there must be a reason why there are two SS commands. So let's check if we run the two commands separately, do they give us different output? So again, let's start with the one that if we run SS that is run, so that's the command that is run. What if we run the other one in the bin? And this one actually shows us that there was the port listening there. So it seems that there was a manipulation of this file here to prevent it from showing this port. And it was placed in a path that is going to be checked first. So this command is never run. What is run is this. So let's check what this command actually does. So we can actually just cut it and see what it has. So the flag was there because once you identify that this was the problem you actually have, you have solved the challenge. But what it actually does once you run it is it runs the actual full command so that everything works as usual. Then it filters out any of this information. So since the actual full command would output this, it would then filter out this information. The -v means out, we don't want to see any of this. If any of this information is in the output, ignore it. So in our case, this output was ignored. And that's how this was able to hide the backdoor. So that was basically it and how the backdoor was hidden. For the net start command, again, if we do the same, we'll see that this is the actual file that is run. But if we go to where is net start, we'll see again, there are two of them. And by what we figured out, this must have been modified to run, then filter out our backdoor. So if we did that again, we would see again, it filtered out our backdoor. So any of these ports wouldn't be visible. And any of these commands would also not be visible. So that's basically it. And I think we've covered all the challenges. So I think I can now head over to the questions in case there were any pending questions. And I think we can also allow participants to chat so that we can actually ask the questions directly. So you are able to unmute yourself if you want to ask any question. I see a question from Benson Masharia. Must we scan the ports from within the server or we can scan from another device with Nmap to identify the backdoor? Actually, you can't. There were some other modifications I did that ensured that you wouldn't be able to view the backdoor if you scanned it outside the server. So if you had run Nmap on the IP of the server, you can even try it now. You will not be able to find that open port. So you had to have been on the server to be able to identify the backdoor. So anyone with a question, you actually can unmute yourself now. Any question for all of the challenges?
Hey, Sikil.
Yes.
Yeah, Benson here. So you
Okay.
mentioned that some users had another way of solving it. Maybe you can show us how they solved the challenge.
The easiest way to solve it was to just grep for the flag. Using the grep, then you grep for the Aspire on all the files of the server. So eventually it would get to a file the file that had the flag. So people would have been very easily been able to just grep for the Aspire word for on all the files on the server, and then that output would have been visible. But that wasn't the intended solution. So afterwards, I did add some changes, some security changes to make sure that you couldn't be able to just grep for it.
Okay, that's okay.
Yeah, so during the competition, it actually turned out easier than it was supposed to be. Anyone else with a question? I think we are well into the second hour. So we will be wrapping up soon. We wanted to cover networking as part of the first week, but since we would take too long, we will cover networking. We'll push networking to next week so that we can have a dedicated session for the networking session. All right. As always, those within our other channels can ask any additional questions after this. That's on our either mailing, social media, chats, our groups, and so on and so forth. So you can ask any additional questions there if you have them. So I think that's it from us. Enjoy your night. And since it's recorded, you can always refer back to this. And we'll also be publishing the actual walkthroughs in PDF format or on our blog so that you can be able to also reference and view the commands and say you want to copy paste and so on and so forth. And also for your future reference. So thank you, everyone, and see you next week.